Okay, on the Chapter 5 unit test, okay, practice test. Okay, so first off, we're going to try to do some matching here. We can say, well, what are the types of reactions going on? And we have zinc, here's an element plus a compound, turns into an element and a compound, so that is a single replacement reaction. So that is answer A. Okay, here we have a plus and a minus, plus and minus, plus and minus, plus and minus, so that's a double replacement reaction. Okay, that's answer D. Here we have an element and a compound, so that's a single replacement again. Okay, and so again, that's answer A. And here we have one thing breaking up into two things. One breaking into two, that's decomposition. So that's answer C. Okay, decomposition. Decomposition. So that's the first part. Okay, next one here. Chemical reaction, the total mass of the chemicals before and after the reaction are always equal. We're talking about the same chemicals before and after, they're just mixed up. So before and after, and that's called the law of conservation of mass. Number 6, which of the following reactions results in a single product? Okay, so we're talking about something plus something turns into a single product. Okay, that is a synthesis reaction. Answer D. For number 7, which coefficients will balance this equation? Okay, so I have a carbon and carbon and carbon. I'm not going to start with there. I'm going to start with sulfurs. So this has 2 sulfurs, so I'm going to put a 2 here. Okay, now I'm going to do my oxygens. I have 2 times 2, 4 oxygens, so I'm going to put a 4 here. And I'm going to put a 1 there. And now I'm going to do carbons. I have 1 carbon. I have 4 carbons. I got 5 carbons altogether, so I'm going to put a 5 there. So hopefully I have an answer that's 5, 2, 1, 4. There it is, answer D. What's the coefficient in front of oxygen? Okay, when we do the lowest whole number coefficients. So here I have NH3, O2, NO2, H2. I've got 2 H's and 3 H's. I'm going to get that to balance first. So I'm going to put a 2 here, and I put a 3 here. That gives me 6 hydrogens on both sides. Now if I have 2 N's, I'm going to put 2 NO2s. And how many oxygens? I have 2 here, and I have 3 here. So on the right side, I have 5 oxygens, so this is going to be 5 halves O2. Now it says do it in whole numbers, so I have to double everything. So I need to have, it's going to be 4, 5, 4, and 6. And it said, what's the number in front of the oxygen? It's 5, so that's answer D. For number 9, what's the coefficient in front of oxygen when the combustion of propane? So now we have to know what we're doing. Plus O2 turns into CO2 and H2O. And so I have 3 C's, so I'm going to put a 1 here, I can put a 3 here. I have 8 hydrogens, so I'm going to do 4 here. And that gives me 3 times 2, that's 6 oxygens here. I have 4 oxygens here, 10 oxygens, so it's a 5 O2. So the question is, what's in front of the O2? It's 5. Okay, how many grams of HCl are needed to react with 3.25 grams of aluminum according to this reaction? So this sounds like I'm going to go from grams to moles, and then moles to moles, and then moles to grams. So it's going to be a 3 conversion factor problem. So I'm going to start off with my given. Okay, 3.25 grams of aluminum. And then aluminum, says right here, is 27 grams of aluminum for 1 mole of aluminum. And then I need to do my mole-mole conversion. So moles of aluminum, 2 moles of HCl. And HCl in the question is 2 moles of aluminum for every 3 moles of HCl. So I'm using those numbers from the balanced equation. And the last thing is I need to go how many grams of HCl. So for every 1 mole of HCl, it says here it's 36.5 grams of HCl. Now I need to work out that problem. Okay, I did make a little mistake here, and I should have put a 6 here. I put a 3. So when I work this out, I get the answer 13.18, which I round up to 13.2. Okay, number 11. Grams of carbon to react to make grams of silicon dioxide. So again, it's the same thing. I go from grams to moles, moles to moles, moles to grams, 3 conversions. I'll change colors. Okay, so I have 75.2 grams of SiO2. That's my given. And I'm looking for grams of carbon. Okay, so I'm going to use that chemical and that chemical. Okay, so SiO2 60 grams for 1 mole of SiO2. Okay, then I'm going to use my mole to mole. So moles of SiO2 to moles of carbon. So this 3 and this is a 1. And lastly, I want to go back to grams of carbon. So for every 1 mole of carbon, that is 12 grams of carbon. And I need to work it out. And when I put it in my calculator, I get 45.1 grams of carbon. Okay, solutions of silver nitrate and calcium chloride are mixed in a precipitate forms. What's the correct formula of the precipitate? So what have I got? I've got Ag plus and NO3 minus mixing with calcium Ca2 plus and Cl minus. So when one choice is silver, go with the chloride, AgCl, because plus 1 minus 1, and the other possibility is calcium going with nitrate, and I need 2 nitrates. But I know my nitrates are aqueous, so I know that is not my precipitate, so it must be the AgCl, which is answer A, and that's the correct formula, AgCl. Okay, which of the following compounds are formed during double replacement reactions? Which one would be a precipitate? So this means use your chart and look at the chart. Now I know it's not KNO3 because potassium compounds are always soluble, and I know that acetate compounds are soluble, and I know that ammonium compounds are soluble. So if I look those up in my chart, they're all going to say AQ, where they're mixing. The answer is copper hydroxide. That'll say solid on the chart. Which of the following would be a precipitate form when barium chloride and potassium sulfate are mixed? Okay, so the same idea. So again, start off, I have Ba2 plus and Cl1 minus, and I have K plus, and I have SO4 2 minus. So my new combinations would be KCl plus 1 minus 1, and another new combination would be BaSO4. Okay, and the idea is either or both of these precipitates. I know potassium compounds are always AQ, so that's not my answer. Okay, BaSO4, when I look that up, it says solid. So of those two, it's going to be BaSO4 only. Okay, in the above reaction, which represents the oxidation half-reaction? So we want to know. So for oxidation, we are looking for somebody whose charge is going up. So here we have zinc is 0 and it's becoming 2 plus, so that's the one we want. So we're going to write zinc on the left side, Zn2 plus on the right side, and then we say which side is more positive. This side is more positive, so that's where we're going to put our electrons. So we're looking for that answer. Zinc turning into zinc 2 plus 2 electrons. There it is, answer C. Okay, which of the following represents the products when Mg is placed in HCl? So here we have an element and a compound. So we're going to get a new compound and a new element, and we're going to get magnesium chloride. Now we know Mg is 2 plus, Cl is 1 minus, so it's MgCl2. And the new element is hydrogen, and we got to remember that element, that hydrogen is diatomic. So which of the following represents the products? We're looking for MgCl2 and H2. There it is, answer B. For 17, 3 strontiums. Okay, so here's an element and a compound, element and a compound. This guy is a single replacement. Which of the following is true? Okay, strontium is oxidized, strontium is oxidized, strontium is reduced, strontium is reduced. Okay, so what is strontium doing? Okay, it is changing from 0 to 2 plus in this compound, because strontium always forms 2 plus. So it is going from 0 to 2 plus. It is being oxidized. Okay, so these are not the right answer. And it's going from neutral to 2 plus, and that is answer A. Okay, what's going on in the above equation? Magnesium is what? Gaining or losing electrons, and oxidized or low. So remember we say that Leo the lion says grr. Okay, so if it's gaining electrons, that's reduction, so that can't be the right answer. And losing electrons is oxidation, so that can't be the right answer. So it's either B or C. And what's happening to magnesium? Magnesium's going from neutral to, in the compound, it's 2 plus. Okay, which side is more positive? This side is more positive, so we put electrons in. So since the electrons are over here, we're saying it's losing electrons, and the magnesium is getting oxidized. That's answer C. Okay, 19. Consider the following process. Solutions of calcium nitrate and sodium sulfate are combined. Classify the reaction. Okay, we got a positive and a positive and negative, so they are going to change partners. So this is a double replacement reaction. So that's the first part. Now, write the balanced equation. So calcium is Ca2+, nitrate is NO3 1-, sodium is Na1+, sulfate is SO4 2-. So the two chemicals on the left, 2 and a -1, so it's going to be Ca NO3 taken twice, and the other compound Na and SO4 +1 -2, so we need two NAs, Na2, SO4. Now when we change partners, the calcium goes with the sulfate, so we get Ca SO4 and Na and NO3 +1 -1. It goes like that. Okay, we got to write a balanced equation, so we need to put some numbers in, and I have two nitrates, so I'm going to say two NaNO3s and two NAs. I already have two NAs, so now this is balanced. Okay, identify the precipitates. Okay, well, NaNO3, we know that that is AQ because all sodiums and nitrates are there. But if you look on the chart, you're going to see that CaSO4 is a solid. So that is the precipitate. Number 20, consider the following process. Nickel metals placed in a solution of cupric chloride. I have an element and a compound, so that's going to be a single replacement reaction. Now, write the balanced equation. So if I have nickel, that's Ni, plus cupric chloride, that's Cu2+, Cl1-, so that's going to be CuCl2. Then I'm going to get a new compound, nickel chloride. I know nickel forms 2+, so NiCl2. And the new element, we're going to get copper metal. Which element is oxidized? Okay, nickel's going from 0 to +2. And who's getting reduced? The copper is going from 2+ down to 0. And the chloride is not doing either one. Okay, 21, consider this process. Methanol is burned in air. So burning, okay, we know that's combustion. Write the balanced equation. So CH3OH, we know we're going to mix it with O2, turn into CO2 and H2O. Because I have one C, I'm going to make one CO2. Because I have 4 hydrogens, I'm going to make 2 H2Os. And on this side, I have 1, 2, and I have 1, 2, 4 oxygens. Here's one of them. So this is 3 more. 3 oxygens is going to be 3/2 O2. Now it says balances with the lowest whole number coefficients. So I'm going to go back and double this. 2, 3, 2, and 4. That's going to be my answer. 2, 3, 2, 4. Now, if 1.5 moles of CO2 are produced, how many moles of CH3OH were burned? I want moles, and I'm going to moles. So moles to moles, I don't have to go to grams, I don't have to go to liters, I don't have to go to molecules, so I just need one conversion factor from moles to moles. So 1.5 moles of CO2, and then I go right to my mole-mole conversion factor. So moles of CO2 on the bottom, and I'm trying to get to moles of CH3OH on the top. And what is it? Am I here? There's 2 and CO2, 2 and 2. So it's 2 and 2. So my answer is going to be 1.5 moles of CH3OH. And that's my answer. 2 points. Okay, the compound Boron Carbide is one of the hardest materials known and used in tank armor, bulletproof vests, and other industrial applications. It's prepared according to the following reaction. Okay, write the balanced equation. Okay, so let's look at this. I have 2 B's here and I have 4 B's here. So if I have one of those, I'm going to say I have 2 of those. That might be good. Okay, now that gives me, I can do carbons. Now I got carbons in 2 places. I'm not going to do that. I'm going to do oxygens. Here I have 2 times 3, 6 oxygens. So this must be a 6. Now on this side I have 1 carbon here and I have 6 carbons here. That's 7 carbons, so this will be a 7. 2, 7, 1, 6. So write the balanced equation. 2 B2O3s plus 7 carbon turns into B4C and 6 COs. So if I have a space, I write in the 1. If I don't have a space, I just leave it out. Calculate the molar mass of boron carbide. Okay, so I got 4 B's, 4 times B, and 1 times C, and I know carbon is 12.01 times 1 equals 12.01. Okay, boron, looking it up, it says 10.8, so I got 10.8 times 4, and that's going to be 40, and so 43.2. And adding those up, I'm going to have, looks like 55.21 grams per mole. If I did that right. 55.21. That looks good. So how many moles of B4C can be produced if 5.5 moles of B2O3 is used? Okay, again, I'm going moles to moles, so that should only take 1 conversion factor like we did before. So my given is 0.550 moles of B2O3. So I just need my mole-mole conversion factor. So I'm going to say moles of B2O3. And I'm going to moles of B4C. So back to my equation. B4C, I used a 1. And B2O3, I have a 2. So 0.555 divided by 2, I get 0.275 moles of B4C. And that's my answer. So moles of those canceled out. Okay, what's the mass of B4C formed if 14.5 liters of CO2 are also produced? So now I'm starting with liters. This is my given. And I'm going to grams, that's mass, so I want grams of B4C. So if I want liters, I'm going to be using my 22.4 liters per mole, and that's at STP. So I'll start here. I'll say 14.5 liters of CO, and I know that there are 22.4 liters of CO in 1 mole of CO, 1 mole of any gas. Now I got to go moles to moles, so moles of CO and moles of my desired, which is B4C. Okay, and I'm going to get to mass, but let's go back. So in my equation, the CO has 6 and B4C has 1. So this is 6 and this is 1. And the last thing here, so for every 1 mole of B4C, okay, I need to know how many grams that is. And luckily, that's what we figured out up here, so I'm going to use my 55.21 number. Grams of B4C, and now I'm going to calculate, because liters drop out, moles drop out, moles drop out, and I have grams of B4C. Okay, for this I'm getting 5.95643, so 5.96 grams of B4C. Okay, so how many atoms are used if 3.2 grams? So again, I'm starting with grams, so I'm going to go grams to moles. Okay, moles to moles. And then I got to go moles to molecules. So I'm going to use that 6.02 times 10 to 23 number. So let's start off with my given. So 32.1 grams of B4C. Luckily, I know my conversion factor right there, so it's 55.21 grams of B4C is 1 mole of B4C. And now it's time for the mole-mole conversion. So moles of B4C for every mole of carbon. And back at my equation, 7 is for carbon, 1 is for B4C, so 7 for the carbon, 1 for B4C. And I'm trying to get to how many atoms. Okay, so I know that 1 mole of carbon is 6.02 times 10 to the 23 atoms, because carbon comes in atoms. And now I just have to do all that math. So luckily, I think the answer is written right down here. Okay, 2.45 times 10 to the 24 atoms of carbon. And that's my final answer. Okay, I just checked that on my calculator. I just did the numbers, and if I just do the numbers, the 6.02, the 7, 55.21, and that, I get 24.5 times 10 to the 23 atoms. And so if I move my decimal point over, then I make that 2.45 times 10 to the 24 atoms. So that's my answer. And that is the entire practice test.